Welcome back, mathematicians. In this video, we are going to find the exact values of the trigonometric functions of 30 degrees and 60 degrees. As a reminder, the radian equivalent of 30 degrees is pi over 6, and the radian equivalent of 60 degrees is pi over 3. So all trig functions that we calculate for 30 degrees and 60 degrees will also hold true for pi over 6 and pi over 3. Let's now look at our triangle below here, where we have a 30, 60, 90 degree right triangle, where we have side values of A, B, and we have a side of C, which we let equal to a value of 2. We need to now find specific values for A and B. To do this, we're going to copy over this triangle so that we have also a side A, a side C, and then the vertical distance is also B. What this means is that we have an equilateral triangle where all angles of the larger triangle are 60 degrees. This means also that every single side has the same value, so they all have a value of 2. What this also means is that if A plus A is a value of 2, then we know that A is equal to 1. Now, by using the Pythagorean theorem, we can find a specific value for B, which is square root of 3. So we now have a triangle that has sides of 2, 1, and square root of 3. I'm going to go ahead and clean this up a little bit so that way I can accurately mark the sides and use them to find the exact values of 30 degrees and 60 degrees. So we have A, which is equal to 1, and we have B, which is equal to square root of 3. We are now ready to find the exact values of each of the trigonometric functions for 30 degrees and 60 degrees. Let's start with 30 degrees, and let's start with sine. So sine of 30 degrees is equal to the opposite side, which is 1, over the hypotenuse, which is 2. Cosine of 30 degrees is equal to the adjacent side, which is square root of 3, over the hypotenuse, which is 2. Tangent of 30 degrees is equal to the opposite side, which is 1, over the adjacent side, which is square root of 3. We do want to rationalize the denominator, so we will do that by multiplying both the numerator and denominator by square root of 3 over 3, and this gives us the ratio square root of 3 over 3. Next, we want to find the cosecant of 30 degrees, which is equal to the reciprocal of sine, or 2 over 1, which is equal to 2. Secant of 30 degrees is equal to the reciprocal of cosine, which is 2 over square root of 3, and this gives us a value, once we rationalize the denominator, of 2 square root of 3 over 3. And then finally, we have cotangent of 30 degrees, which is the reciprocal of tangent, or square root of 3 over 1, which is equal to just square root of 3. Next, we want to do the same thing with 60 degrees, and we'll start with sine. So sine of 60 degrees is equal to the opposite side, which is square root of 3, over the hypotenuse, which is 2. Cosine of 60 degrees is equal to the adjacent side, which is 1, over the hypotenuse, which is 2. Tangent of 60 degrees is equal to the opposite side, which is square root of 3, over the adjacent side, which is 1, so this ratio becomes square root of 3 once reduced. Next, we're going to go over cosecant of 60 degrees, which is equal to the reciprocal of sine. This will be 2 over square root of 3. Then you need to rationalize the denominator to get 2 square root of 3 over 3. Secant of 60 degrees is equal to the reciprocal of cosine, which is 2 over 1, or just 2. And then finally, find cotangent of 60 degrees, which is equal to 1 over square root of 3. That's the reciprocal of tangent, which is equal to square root of 3 over 3. Let's now use this information to find the exact values of each expression. So first, I need to find the tangent of pi over 6, which, remember, is equal to tangent of 30 degrees, since pi over 6 is the radian equivalent of 30 degrees. Tangent of pi over 6 is equal to square root of 3 over 3. I also need cosine of pi over 4, which you might recall in a previous video, we discovered it's equal to square root of 2 over 2. Next, I'm going to replace each of these trigonometric functions with their equivalent value. So tangent of pi over 6 gets replaced with square root of 3 over 3, and cosine of pi over 4 gets replaced with square root of 2 over 2. Now I need to go ahead and find a common denominator to combine them into one fraction. So I'm going to multiply the first ratio by 2 over 2, the second ratio by 3 over 3. This gives me 2 times square root of 3 over 6 plus 3 times square root of 2 over 6. Finally, my answer will be 2 times square root of 3 plus 3 times square root of 2 all over 6. For the second problem, I want to first identify tangent of pi over 4. Tangent of pi over 4 is equal to 1. Sine of pi over 6, which remember is really sine of 30 degrees, is equal to 1/2. I then replace tangent of pi over 4 and sine of pi over 6 with their equivalent value. Keep in mind that when you are looking at a trigonometric function being squared, tangent squared of pi over 4 can actually be rewritten as tangent of pi over 4 quantity squared. So tangent squared of pi over 4 can be rewritten as 1 squared. Sine squared of pi over 6 can be rewritten as 1/2 squared. Square both of these values to get 1 plus 1/4, and then find the sum to get 5 over 4. All right, guys, good luck.